I recently did a video where I redesigned these boards. Now, these were used or designed in order to replace selenium rectifiers on tube radios or tube gear in general. And that is the one that replaces the selenium rectifier. And then these two were to replace the filter caps, where you put two filter caps on here. This goes on the underside. And the way I designed this particular board some time ago, and I ordered quite a lot of them, is that this is all in one board, and then you would break that off, you'd break that off, and you'd break that off. So you've got two replacements for the filter caps and one board like that. Well, the result is that I ended up with quite a lot of these because I put 3 to a board. That makes the boards a lot more expensive, I found. So I decided to change that. The other thing is that I ended up with a lot of these extras because I would use one and I'd be left with another one. So again, a waste. Now, when I designed these new ones, I figured I would do it properly. You'll see that I've got 2 different sizes here, and that was done on purpose. The reason for this is that I have come across 2 types of selenium rectifiers generally. One type is the rectangular one like this, and this is what I've got now on the SABA. So this was designed to fit on that, and then of course that was also changed. This is now for the filter capacitors. There are a few changes which I'll point out in a minute, but you'll see that I've made a few changes here as well. I've made some of the holes bigger because I had problems fitting some of those resistors in here. And I've also made the spacing between the legs of the diodes a bit bigger. So there have been a few minor changes, but ultimately this thing is exactly the same size as the previous one. And you'll notice that the holes there are exactly in the same place. Now I'll show you how this fits into the space of the selenium rectifier that we're trying to replace over there. This over here is a different story. This here was too small. And what I found is that to fit 2 47 microfarad capacitors on here, you do get them. I do have them that fit on here, but they're very specific. And most of the 47 microfarad thin versions are slightly bigger than that. So I ended up with a few problems trying to fit them in there. There's one other problem, as you can probably see, is the holes were too small. And then the ground tab, or the ground hole, and I'll show you how these fit in a minute, that was also too small. And then more importantly, the connectors for the wires that come from the cap, in other words, the connectors to the capacitor, the way this is that 2 capacitors are common grounded, and then there's 2 pins or 2 holes for that capacitor, 2 holes for that capacitor. In this case, I had that, but they were very small and they ended up very, very close to the capacitors themselves. So they weren't comfortable there. They really made life quite difficult. So I decided to redesign this, and this is the result. This is the bigger version. It also breaks off from that, but this is 1 unit. Each board is 1 pair or 1 set. And I ordered 10 of these because I do use them, and I know now that they won't be wasted. So that's that one. This one here is slightly different. This one here is exactly the same size and shape and everything else for the capacitor. But this is slightly different, and the reason for this is that I came across 2 of these recently. These are selenium rectifiers as well. It's a bridge rectifier. I've had 2 in a row almost, very recently. And when I tried to fit one of these boards there, I had a space problem. So I decided to make a version that's slightly smaller. The difference here is that the diodes are still fairly wide apart, but they're slightly closer than that one there. And also, instead of having 3 resistors to drop the voltage, which you can use to either make the power of that resistor, of the resistors, larger by making it 3 in parallel, or you can adjust the value by putting capacitor resistors in parallel. This one only has 1. So you literally have to work out what value you need. You can tack them on, just stack solder a resistor on here. And when you finally know which value you want, you put the final resistor in there, but you've only got 1, okay? And it's not exactly the same shape as this, but it's close enough. And the way that this is going to work is it's sort of going to be fitted into the space where that one was. That's usually fitted like that. So this will be fitted over there with a spacer. I'll find a way to put those in the board on the chassis. But that's the difference between these two. And as you can tell, it's quite a bit of a difference. And as usual, PCBWay sent me these boards. They're perfectly done. I really like them. Again, perfect execution. And this time, no mistakes. Certainly they've never made any. I have made a few in the past. So PCBWay is sponsoring this video. I want to thank them for it and suggest you go and visit their website for your needs as well. So let's look at the real-world application of these things. Here's the SABA Meersburg 100, and it uses this type of selenium rectifier. And as you can see, this is slightly smaller than that, but the positioning of the screws will mean that it'll fit exactly where those are. I'll be able to put the 4 diodes on here and the dropping resistor, because this would be dropping more voltage than the silicon diodes. So this could fit quite comfortably on there. You still need to put a spacer on there. Again, what I've done is I've got the AC points over here. There's AC in. And as you can see, I've positioned them in the same way, same orientation. And then we've got the positive over there, which is there, and the negative over here, which is there. So the idea is to make this as similar as possible so that the replacement is as unobtrusive as possible. So that's the sort of thing that goes on here. And I'll be populating one of these in a minute to show you the result. Now, what about the filter capacitors? This is a typical, well, actually not a typical, but this is a dual cap, 50 microfarads times 2, 350, 385 volts. The way this one is done is that it's actually insulated from the chassis, and you've got the 2 coming out here. The common ground is over here. So you can already see where this is starting to look similar. Most of the ones we use, and I don't have a dual one handy at the moment, are more like this. They've got a ground tag, or various, normally it's 3 ground tags. These pins that come through the chassis, and then you twist them. And then you normally have the 2 connectors coming out of the 2 pins coming out of here for the 2 capacitors. So the way this thing works, the way this thing was designed is you take your pins for the old capacitor, you desolder everything, and you bend it down. So you get those out of the way. They're totally out of circuit. And then you take this thing and you're going to populate it, and you'll fit it into something like this, like there, for example. And with solder on there, you can seal it in place. And that is the ground, and the chassis is the ground. So you've got this thing perfectly prepared to use in one of these replacement capacitors, or underneath the old capacitor. And then, of course, you've got the 2 pins there, the 2 pins there, so you can connect whatever's coming to the other capacitors to those pins over there. Remember, that's one cap, and that's the other cap over there. Sometimes you might have 3 on one and 1 on the other. You just make sure that you connect them to the right spot. And generally, the capacitor is slightly narrower than this, so this thing fits pretty nicely. So you can do that. Or you can actually use some thick wire, solder it to there, put this as a bit of a standoff, and you can make this, raise this a bit more if you need to. But the idea is that this thing works quite well, and you don't end up having to solder capacitors just in the air, or fit a separate solder block to the radio where you don't really need to. But let me show you what this looks like when it's populated. The type of capacitors that I prefer for this job are actually something like this. This is really a no-name brand, but it's bought from a reputable supplier here in Portugal. This is 447 microfarads, 450 volts, and they are fairly high, they're fairly long, but they are very narrow. So if you look at this, you can fit that in there. It would help if I did it the right way around. There's one. And there's the other. And they fit perfectly. All you do is solder down there. Normally what I do is I make sure that I cut these, bend them, and then solder them and cut them off so that they hold well, but they don't actually protrude too much. And there we have it. Now you can go one step further. You can actually put some heat shrinking over the top here and heat shrink these together. That's something I sometimes do as well. But normally I don't even bother with that. But as you can see, the actual pins, those 2 would go to the positive of that capacitor. Those 2 would go to the positive of that capacitor. The pins are actually very accessible. You can actually solder from the top, so you don't have to worry too much about getting on the underside if you don't want to. You can put this in place and then solder the pins on there or the wires to there. So this thing works pretty well. But there's also the other possibility, and that is that if you've got a bigger capacitor like this one, which is obviously thicker, you can actually get away with it, and I've done it before. Now, you have to use a little bit of creativity on here, because first of all, you can see these pins are, or this pitch is slightly different, but it's not an issue. So what you can do is you put them in like that, leave it loose, do the same on here. Now you got a problem, right? Because these things will not fit together well, but if you do that, and you can actually get them closer than that, they bend in place, and again, they will hold very, very well, especially if you put some heat shrink on there. And again, you've got the connection for ground down there, and you've got the 2 pins on there. Normally, what I'll do is I'll just take a pliers and bend these in place, and they fit very snugly, very close to the board itself, so they protrude very little at the top. Now remember, in some cases, these might be too tall. You don't want them sticking at the bottom of the radio, so you might want to use thicker ones and do that. Now I had to make a compromise. I had to decide to let them stick out, because this can't be too big. If this diameter was too big, it would start protruding out from the bottom of the capacitor, okay, because they're usually smaller than this one, and then you've got all sorts of components around. I didn't want to influence that, so that's why this was done like this. But this works really, really well. And I've used both. I've used, in some cases, the thicker ones. There are some Nichicon ones that I use quite often, which are this size. This is, I think it's 18 millimeters. And there are also some Nichicons in this size, but they are very expensive. So I normally would try and get the Nichicons in that size, and I would do it like this. But there we go. It's multi-purpose, and it works very well. What about the Selenium Rectifier replacement for silicon diodes? Well, this is really what it is, and we just populate it. And here we are, all done. The 4 diodes are in here, so 4 1N4007s. That's perfectly adequate in terms of current and voltage rating. They fit perfectly on there. They've been bent back on the bottom so that we've got as little sticking out the bottom as possible. And then I've got 2 resistors on here. Actually, I realized I put them the opposite way around. I try to put them together, but anyway, this will have to be replaced anyway. This is 2 by 220 ohm resistors. They're in parallel, so it's giving me 110 ohms. I'm not sure what resistance I will need. I think I'll probably need another 220 in parallel to give me sort of 70 ohms when I use it to replace the Selenium Rectifier on the SABA. But again, as I said, I'll put this on. If the voltage is too low, I put on another resistor, make the total series resistance slightly smaller. If it's too high, I'll take one of these off. You know, you can play with that, get the right resistance. At the moment, these are 2-watt resistors, so between them, we've got 4 watts because they're the same value. They will share the power, and this just makes it easier to play with, to replace those things without worrying about overheating. I made the resistors stand out a little bit from the board to improve airflow. So all in all, this thing works very well. And all in all, this set of boards is precisely what I've been needing. I've ordered 10 of those, and I believe 10 of those. So I've got lots of stuff here for my radios. I'll be using all of them, I'm sure. And I'm going to share this on the share section of the PCBWay website. I'll put the link to that in the description below, both for these and for these, so you can choose which ones you want. And if you want to order some for yourself, go ahead, just click on there, and the order is sort of made almost automatically. So anyway, I hope this proves useful to you. It's certainly useful to me. Yeah, I like that. I really do. And I will see you again soon. Hope you enjoyed that. If you did, click like, share, subscribe, and all that jazz. And if you want to support the channel directly, you can do so on Patreon. Thanks for watching. Bye for now, and stay safe.